Hey everyone, welcome back to the channel. And today we are going to start a new series on big data. So let's get started. In the era of computing, various types of software systems are required and various types of software systems are developed. The software systems are such as system softwares like Windows, Mac, Linux, etc. Then programming languages like Python, C, C++, Java, application softwares like Microsoft Word, PowerPoint, Photoshop, etc. Then data processing applications such as MySQL Server or MongoDB, the various kinds of databases or Excel, these kinds of tools are came in picture. Then web and mobile applications. As soon as the internet grows, the various websites are providing services like e-commerce, etc. And those are through the web and mobile application. Then cloud computing comes to the picture and it revolutionized the internet. And now the era of AI and ML is growing phase. Now our focus is on data processing applications, and let's see. In the data processing application, COBOL was the first attempt in the data processing. COBOL processes the data in the structured format like text and CSV formats. After that, companies like Microsoft and Oracle came into the picture and developed various types of database systems. Those are called RDBMS or Relational Database Management Systems. But sooner the data is growing as the internet grows. The companies like Teradata and Exadata came into the picture and they deal with the big volumes of the data. There is a very popular saying in the internet that everything will come and go, but data will always grow. And this is a very popular saying. It's not only about the growing data. The data is not growing in only structured format. As the internet revolution keeps growing, we have various types of data like XML, JSON, databases, text, docs, PDF, MP3, video files, images, etc. etc. And it is very hard to manage all these kinds of data in RDBMS and it's not possible as well. So the first attempt is categorization of the data, and the data is categorized into the different categories. The first one is the structured. Here you can see various databases such as Oracle's DBF, that is a database file, or you can say various formats like CSV text. We store the structured data in the form of tables in that different types of files. Then semi-structured data. This data don't have a proper structured or tabular structure, but underlying it has a key value relationship and the structure. So XML and JSON are the example of the semi-structured data. And unstructured data is like images, audio, video, documents, PDFs. Those are very unstructured data. Here is one example for semi-structured data. The first image you can see here is JSON, and you can see here it don't have a proper structure, but it has a key value mapping and a key value structure in it. And the second one is the XML format, and it is also a semi-structured data. So let's come to the another factor of the big data, and that is the velocity of the data. Here, let's see some facts about the internet. You know, the popular social media platform Discord exchanges 4 billion messages per day. Google processes 6.3 million searches per minute. Instagram handles 2.8 million views per minute. And New York Stock Exchange handled 2 to 6 billion price changes or ticks per day. So this is all handling at a very big speed. So that's why the speed or the velocity of the data is again one crucial or important factor. From here, the big data problem came into the picture, and it is mainly three parts of the big data. The first one is volume. Nowadays, it is very easy for the companies to accumulate the data of petabyte or exabyte scales. Some big companies like Google and Microsoft handles the data at exabyte level. Then the variety of the data. Companies have to deal with the data in various different formats, as I have shown you, various file formats, various sources. And the third problem is velocity. The data is growing at a very fast speed, as we have checked some facts about the internet in the previous slide. So these three main things, velocity, volume, and variety. So this combinedly contributes as a big data problem. So how the big data problem is solved? With the help of big data platforms. And what the big data platform promises? They store high volumes of data at very high velocity, accumulate the structured, unstructured, and semi-structured data, then process high volume of data at very high speeds. The big data solutions are divided into two types of the systems or two types of approaches. The first approach is monolithic approach. Here, one big system or one big computer or server is there. Just imagine it has 128 virtual CPUs, 528 gigabytes of RAM, and a very big disk or SSD. So it handles the data at a very big scale. But it is only one system, that's why it is called monolithic architecture. Then distributed architecture came into the picture. It contains various small servers with small capacity, but we have distributed everything in multiple computers or multiple servers. That's why it's called the distributed architectures. So let's see some things about the distributed architectures. So some comparison. The first is on scalability. You can see if we want monolithic architecture to scale. Right now your data processing is at 520 gigabytes of RAM, but as your organization grow, you want more. So in that scenario, you want to buy a bigger system and you want to process the data. You have to process the data on that bigger system. But in the case of distributed architecture, there is a very simple thing. You can just add new system or new servers and you are good to go. The second biggest problem is fault tolerance. So what fault tolerance is? If your monolithic system breakdowns or if some downtime is there, then your whole system goes down and your services as well. But in distributed architecture, if any node goes down, either it can be replaced or it is removed. And with the help of other nodes, your data is there, and that's why your system is live as well. So this is called fault tolerance. Then the third point on which the big data systems have to be sufficient or have to be promising is cost effectiveness. And in monolithic architecture, if your requirement grows, you have to purchase new system and that is very capital intensive and costly. But in distributed architecture, you start a small with a less number or minimalistic number of server as per your requirement. And as your requirement grows, you can add more and more server and scale your organization or your big data platform to handle the requirements. So this is a very cost effective and you don't have to bear upfront very high capital expenditure. And nowadays with the cloud offerings, you can upscale as well as downscale in few minutes. Now, these all problems are solved. The first serious attempt to solve this problem was Hadoop. Let's see what it is. So what Hadoop promises? Hadoop gives us the three category of services. The first one is Yarn, that is yet another resource manager. And here it is first clustered computing framework. Or here it will manages all your resources across the multiple servers or multiple nodes in distributed system. Then HDFS, that is High Hadoop Distributed File System. And Hadoop Distributed File System will provide you your data storage across the network of computers or nodes. And then MapReduce, it's a parallel processing engine, and MapReduce easily processes your data across various types of nodes, various types of servers in the parallel. So your data processing is also faster. So this is the attempt to solve the big data problem. In the next lecture, we will see in detail about the Hadoop. Till then, keep learning, keep growing.